Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
It's a beautiful day. Welcome once again to class. On the board, we have the question number 4 of the 2023 NECO theory question. And remember, this is our 11-day maths challenge. And today happened to be the day 4 of the challenge. So if you have not subscribed to this channel, kindly do so. Share the link with your friends. Now, looking at the question, we find out that the first question happens to be an exponential equation. Why is it an exponential equation? Because at the powers, right? Exponent means power, right? We have unknowns. You see x, 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 right? That tells you that it's an exponential equation. Then the B part is differentiation, and specifically it's a function of a function. So let's go right into the solution and let's see what we would obtain. Yes, this is what we have. What I'm going to do now is to see how I can make 27 to be 3 to the power of something. And I know that 3 times 3 times 3 is 27. So I'm going to say here, this 27 means 3 to the power of 3. I put that in a bracket, then the power, I write it out, 2x minus 1 times. Now 1 over 3 can be expressed as 3 to the power of negative 1. The negative here is because of this division, right? Then this 1 is because this 3 here is carrying a power of 1. Good. Then carrying a negative power, then I'll do it like this. If I use this negative to expand everything here, I will have minus 3x minus 2. So I'll put that as minus 3x and minus 2. It's the same thing as what I have here. Then 9 can be expressed as 3 to the power of 2. Then the power here is x plus 3. Good. I put that in a bracket because this 2 will expand everything I have there. Now, from the law of indices, we know that if we have a to the power of x times a to the power of y, as long as the bases are the same, the rule says that you multiply the powers, you add the powers together. And also, if you have this rule where a to the power of x is carrying another power of y, the rule says that you write out the base, then the powers multiply. Right? Good. That's what we are going to do here. Expand this, expand this, expand this. Before we will now what? Use the other rule of addition. Good. Therefore, expanding this will give me 3 times 2. This will give me 6x minus 3. Then multiply. Let me use a dot. Then 3 again. Minus 1 times this gives me 3x, because minus times minus is plus. Then minus times minus is plus here. That's plus 2 equal to 3. Then 2x plus 6. Good. Now you see under multiplication, the bases are the same. You now use the rule I just mentioned that you have when you have a to the power of x multiplied by a to the power of y. As long as the bases are the same, you add up the powers. This becomes a to the power of x plus y. So I'm going to do the same here. So this will now give me 3 to the power of 6x minus 3. Then I will add up what I have here plus 3x plus 2 equal to 3 to the power of 2x plus 6. Good. Then simplify by adding up like terms. So 6x plus 3x is 9x minus 3x plus 2 Minus 3 plus 2 will give us minus 1 equal to, then I have 3 here to the power of 2x plus 6. Wahoo! Wahoo! Now, in indices or in exponential equation, once you find out that you have equal bases like this, right? It means that the powers are the same. The same way, if you have equal powers, that means one of the bases should be an unknown. It implies that the bases also can also be the same. But in this case, the bases are the same, therefore the powers are equal. So you state that since the bases are the same, therefore are equal. So I can now equate 9x minus 1 to 2x plus 6. So if I collect like term, if this comes here, it turns to negative 2x. If this negative crosses this equal to sign here, it turns to positive. So 1 plus 6 becomes what? 7. So permit me to now replace this with 7x. Then 1 plus 6 is 7. Permit me to write 7 there. Then at this junction, I will divide both sides by what is multiplying x, which is 7. Divide both sides by 7. 7 will cancel 7, right? Then 7 in 7 is 1. Therefore, my x is equal to what? 1. And you can test by putting the value of 1 back into this equation. You are going to find out that what you have in the left hand will be equal to what you have at the right hand. Good. Now, let's look at the B part of the question. Now, we are asked to differentiate what we have in the bracket to the power of 4. Whenever you see a question like this, just know it's a function of a function. How do I know this? You can equate what you have here to be y. So we are going to say let y equal to what you have here, which is 2x squared plus 5 all to the power of 4. Good. Then you will not say what is inside the bracket, as assign an alphabet to it. So I will assign the alphabet u to it. So I will say let u be equal to what you have in the bracket, which is 2x to the power of 2 plus 5. Now this is what we are going to do. If I differentiate u with respect to x, knowing that the general form of differentiation, if you have y equal to x to the power of n, looking at the general way of differentiating, if you are to find dy dx, dy dx will now be this power. You take the power, you multiply what you have here, then you take 1 away from the power. So, for instance, if you have y to be equals to x to the power of 3, you take this 3, you multiply the x, what would you get? You will get 3x. Then you take 1 away from the power. 3 minus 1 gives you 2. Now, what if you have y equals to 5x to the power of 2? What would you do? Simple. Dy dx is this 2 times everything you have here. So 2 times 5 will give you 10. Then you write down the x. Then 2 minus 1 is 1. So x to the power of 1 is still x. So if you differentiate this, you are going to get 10x. So I'm going to apply that same principle here to differentiate what I have here. Then mind you, when you differentiate a constant, you are going to obtain 0. Why is it like that? Because, for instance, if you have y to be equal to ordinary 3, it means that this 3 here is the coefficient of x to the power of 0. Because we know that anything to the power of 0 is 1. And 1 times 3 is 3. So if you attempt to differentiate this using dy dx, you are going to say 0 multiplied by 3x, then 0 minus 1. For the fact that 0 is multiplying everything renders this to become 0 when you differentiate. So using everything I've explained now, I want to differentiate this u with respect to x. Doing that, du dx, when you bring this here, this becomes 4x, then 2 minus 1 is 1, which is the same thing as 4x. Good. Then if you differentiate this, you get 0, right? Now that we know that u is equal to this, we can now say that y is equals to u, because this has been made u, right? Also, y is equals to u to the power of 4, right? And if I differentiate y with respect to u, dy du will give me 4 times what I have here, which is 4u. Then 4 minus 1 gives us what? 3. Good. Now is the moment of truth. To now obtain dy dx, you have to multiply what you created, which is what? Du dx times dy du. So du over dx multiplied by dy over du. How do you know you are correct? When du cancels out du here, you have dy over dx equal to dy over dx. Good. So now, what is du over dx? Du over dx is 4x multiplied by, what is dy over du? 4u to the power of 3. So I'm going to do it like this. Multiply by 4 u to the power of 3. Now 4 can multiply 4. This gives us 16x. Then u to the power of 3. But we can't leave our answer like this, because we have said that u is equals to 2x squared plus 5. Therefore, we can say dy dx is equal to 16x multiplied by everything I have here, which is our u, which is 2x squared plus 5. And u is carrying a power of 3 here. So this is the result I will obtain if I differentiate what? This particular question. Good. Now I want to show you a very fast way to differentiate this question if you see it in an objective exam. That is a multiple choice question exam, where you have to pick either A, B, C, or D. It's simple. You don't need to do all of this, right? Because multiple choice exam talks about speed and accuracy. I decided to leave only the results here, right, for us to compare. So what you need to do, if you see it in an objective exam, just take these two here, differentiate this part. If you differentiate here, what would you get? You will get 4x, right? Good. Then you take this 4, multiply this 4x. Then this power here, reduce it by 1. So rewrite everything you have here. When you reduce this by 1, this gives you 3. So 4 times 4 is 16x. So 2x squared plus 5, all to the power of 3. The same result, different approach. So this brings us to the end of today's class. If you are yet to subscribe to this channel, kindly do so. Do share this video to your friends and loved ones. And we'll meet tomorrow for the next part of our maths challenge. Bye for now.